Hello, I'm Scott Hogg, and I'm going to share with you the business case for your enterprise organization to deploy the Internet Protocol version 6. Before we talk about IP version 6, a brief word on IP version 4. The Internet has experienced exhaustion of the global supply of public IPv4 addresses. Regional Internet registries allocate addresses to companies in their respective geographic regions, and their supply of public IPv4 addresses ran out years ago. In other words, all of the public IPv4 addresses have been allocated, there are no more available. In this graph, we see the burn down from the 5 RIRs around the world and observe the scarcity of public IPv4 addresses. If your organization requires more public IPv4 addresses, then you now must buy them from another company. You must go through the address transfer process, which can be an expensive transaction. As a result of IPv4 address scarcity, there's an increased fragmentation of the IPv4 address prefixes. Subnets get segmented into smaller and smaller networks with increasing utilization and a higher number of hosts on those IPv4 networks. Increasing density in the internet population has been occurring since the 1990s. Increased density often results in readdressing, which can be costly operational expense and can be risky for complex applications. Continued growth of the internet causes ballooning internet routing tables. Imagine where the regression line on this graph extrapolates to in 10 years. Organizations' current routers will run out of memory, and companies should be budgeting for these costly future upgrades. With this increased IPv4 address scarcity comes an increasing reliance on network address translation. Many service providers have implemented large-scale network address translation systems and now provide only private IPv4 addresses to their subscribers. Therefore, the subscribers' IPv4 internet traffic needs to be backhauled through the NAT, and their connections compete with many thousands of other subscribers to get through and reach the internet. This adds latency, delay, jitter, and potential connection loss when using IPv4. As a result, IPv4 addresses are only locally significant within their respective networks. This makes reputation filtering difficult, increases the anonymity of attackers, and reduces security practitioners' situational awareness due to the numerous address overlaps. NATs force applications to adjust to the wide variety of NAT behavior and break the ideal end-to-end model of the Internet Protocol. New companies and expanding businesses need a plentiful supply of unique Internet addresses, and they won't be able to cheaply obtain them. Companies growing by acquisition won't have the unique non-overlapping addresses they require, thus perpetuating a cycle of readdressing acquired company networks. Furthermore, many enterprise organizations are even struggling with the limitations of their supply of private RFC 1918 IPv4 addresses, especially when it comes to deploying large-scale systems such as cloud and IoT. Numerous IoT devices could also benefit from native IPv6 connectivity. Billions of connected devices require billions of addresses, and this can't be achieved with the scarcity of either public or private IPv4 addresses. The internet can't continue to grow with IPv4. IPv4 is stifling innovation. Organizations can't indefinitely sustain their current business models using IPv4. And this won't work with the only approximate 3.7 billion usable public IPv4 addresses. Today, approximately 6 devices sit behind a NAT mapped to a single public IPv4 address. One of IPv6's most well-known features is its plentiful supply of globally unique 128-bit addresses. With 340 undecillion addresses, you can deploy any imaginable network with this large-scale space. IPv6 therefore has benefits of addressing all the public internet systems with non-overlapping addresses. IPv6's plentiful addresses means that network address translation is not required when communicating with cloud environments, IoT, or when an acquisition occurs. IPv6 can be used natively to communicate between companies. Direct communication is possible, and backhauling communications through NATs is not necessary. This restores the intended end-to-end model of the Internet Protocol. If each IP address equaled 1 gram, IPv4 would be a floor or so of the weight of the New York City Empire State Building, where IPv6 would be 56 billion times the Earth's weight, offering a possible 64 billion addresses per square centimeter of the Earth's surface. Therefore, every node on the internet could have its own 4.3 billion addresses, 2 to the power of 64 times over when using IPv6. IPv6 is not new. IPv6 has been standardized since the late 1990s and has been under development for many years. IPv6 is now a full internet standard, and the internet has been using IPv6 for over 20 years. A decade ago, we had mostly IPv4 networks with small pockets of IPv6. Today, networks making up the internet now use both IPv4 and IPv6 simultaneously, routing across the same physical network links. You don't need to switch directly from IPv4 to IPv6. The recommended transition approach is to simultaneously run IPv4 and IPv6 in parallel, making your systems dual protocol. Then you'll eventually disable IPv4, leaving an IPv6 only network. Your systems already support IPv6. IPv6 is implemented in all modern host operating systems and is enabled by default and works automatically. Your firewalls, routers, switches, wireless infrastructure, servers, laptops, mobile phones, tablets, and much more already support IPv6. IPv6 just needs to be enabled on the network with a few simple commands on the network devices. To deploy IPv6, there isn't anything you need to purchase. Much of what you already have in your environment already supports it. It's just a matter of turning it on. Now we are in the middle stage of internet transition to IPv6, where many networks run v4 and v6 side by side. Virtually all core internet service providers now offer IPv4 and IPv6 connectivity subscribers. This may even be provisioned by default unbeknownst to their customers. A large percentage of people already have IPv6 enabled devices connected to their IPv6 enabled mobile service provider network. Most mobile devices use native IPv6 today, and residential IPv6 internet connectivity is increasing. If you own a modern mobile device with a major wireless carrier, you're probably already using IPv6 and didn't even realize it. Now we are starting to move into the late stage of the transition to IPv6, where we are even starting to disable IPv4 in certain environments, leaving only IPv6. In fact, your mobile device may already be using IPv6 only. An increasing number of content providers now support IPv6 internet connectivity to their applications, and now many of the world's top websites use IPv6. This graph shows that many of the top 1,000 websites use IPv6. An interesting note here, the more popular the website is, the more likely it is to use IPv6. It's important to remember that for every web page that loads over IPv6, there was one less web page that loaded over IPv4. The transition to IPv6 can reach and surpass the tipping point as deployment gets underway. The internet has been running IPv6 for nearly 20 years. IPv6 traffic volumes have increased substantially in just the last 10 years. This graph shows the worldwide IPv6 traffic volumes observed from Google's global perspective. Every year, the amount of IPv6 traffic Google receives worldwide increases by 5%. It is easy to see that IPv6's usage has increased in the past decade. Google's networks receive over 52% of their traffic originated from within the United States over IPv6 transport. That means that 48% of their connections are received over IPv4. If your organization is waiting until Google's IPv6 traffic volumes reach 50% to embark on your own IPv6 journey, then the time to start is now. This Asia-Pacific Network Information Center Regional Internet Registry site shows the IPv6 capable rate by country. APNIC statistics show that the amount of IPv6 capable devices in the United States is now over 57%. IPv6 is now used by the majority of internet users within the United States. Some entire countries are surpassing 50% and even 70% IPv6 internet traffic. In fact, IPv6 traffic volumes are now surpassing IPv4 traffic volumes in many countries around the world. Numerous countries around the world now have an abundance of IPv6 enabled internet connected devices. We can see that many countries are now using more IPv6 and less IPv4. Therefore, IPv4 is becoming the legacy Internet Protocol version, and IPv6 is now the dominant Internet protocol. There is now documented evidence showing that IPv6 can perform better on average than IPv4. Therefore, you want your customers to be able to reach you over IPv6 because it could be faster. But you'll also want your end users to use IPv6 to reach their internet applications faster. Back in 2016, we started to observe that IPv6 communications were faster than IPv4. And in 2021, Akamai observed that IPv6 enabled, and especially IPv6 only T-Mobile devices were much faster reaching IPv6 enabled CDN services. The round-trip time improvement comes from the fact that IPv6 enabled end-user devices reach IPv6 enabled web services faster because those connections don't require address translation. APNIC collects and documents measurements of round-trip time for v4 and v6 and compares them. This graph subtracts the v4 latency from the v6 latency, and if the IPv6 latency is a lower number of milliseconds than IPv4's latency, then this results in a negative number. We can see that the RTT is negative, meaning IPv6 is faster on average, for all countries and regions with the exception of a few remote geographies. A couple of years ago, these measurements showed that IPv6 was faster. These measurements were influenced by many mobile devices that are already using IPv6 only communications, and they needed to pass through protocol translators to reach IPv4 only websites and applications. Now we see that the performance gap is reducing as more end-user devices and more applications use dual protocol connectivity. Now we are seeing more websites and applications starting to use IPv6, and the performance gap between v6 and v4 is narrowing. IPv6 only devices can access the increasing number of dual protocol websites over IPv6 directly without having to pass through protocol translators. If your organization wants to continue to remain relevant to the large number of internet-connected systems already using IPv6, then you need to implement IPv6 now. Consider the performance improvement that your customers using IPv6 only devices will experience once you make your public-facing applications use IPv6. Use IPv6 if you want your public-facing applications to be accessible to the broadest internet population, and use IPv6 on your internet public-facing applications if you want to take advantage of the performance improvements of IPv6. IPv6 is not a passing fad. IPv6 is an eventuality and is inevitable. The global transition to IPv6 is already underway. An IPv6 internet already exists, and IPv6 internet content exists. Your network devices and hosts are already IPv6 capable. It's just a matter of turning it on. Organizations are migrating to IPv6 to be able to communicate with the broadest range of internet users. You will want to IPv6 enable your applications to be able to communicate with the broadest population of customers, partners, vendors, suppliers, employees, and everyone. Companies should be planning to transition to IPv6 sooner rather than later to preserve internet business continuity. Furthermore, starting to move some networks to IPv6 only can reduce operational costs of having to maintain two protocols running on the network at the same time. If your organization is connected to the internet, then you need to prepare to deploy IPv6 now. If you don't know where to start, then we can help you plan for the IPv6 deployment and teach you how to do that. We can help you begin and make rapid progress towards IPv6, helping you gain a competitive advantage and preserving your ability to communicate with the internet. Leveraging our expertise will help you accelerate your organization taking advantage of IPv6's benefits. Starting with a business case is a great first step. Getting your teams aligned on the goal of IPv6 implementation helps organizations prioritize those parts of the networked environment that can derive the greatest benefit from IPv6. From there, you get organized, start to develop your initial architectures and designs before moving on to low-level configurations prior to implementation. What are you waiting for? Hogg Networking provides world-class IPv6 consulting and training provided by consultants with decades of IPv6 experience. Please contact us so we can discuss how we can immediately help your business get started with IPv6 deployment.